Hello everyone, in this course we will talk about RAID, redundant arrays of independent disks. In the early days of computers, the capacity of hard disks was relatively small. Large capacity hard disks are more expensive. With the same capacity, the price of a single hard disk is much more expensive than the combined price of several small capacity hard disks. So some computer technicians think, if we can use several small capacity hard disks to form a large hard disk. In this way, the cost on the hard disk can be greatly saved. Thus, RAID was born. With the continuous development of storage technology, to the modern, the single drive capacity is greatly improved. Now the single disk capacity can reach 10 TB, and the price is no longer expensive. But in the development process of RAID technology, people have discovered the advantages of RAID technology, fault tolerance and data security. RAID is composed of multiple independent hard disks combined into a large capacity disk group. Using this technology, data can be cut into many sections and stored on each hard disk separately. RAID can give full play to the advantages of multiple hard disks, which speed and throughput exceed a single hard disk. In addition, there is fault tolerance that a single hard disk does not have. There are more than a dozen combinations of RAID levels, and commonly used are RAID 0, RAID 1, RAID 5, and RAID 10. First, RAID 0. At least 2 hard disks are required. Suppose we store a data packet A, B, C, D, E, F. The storage method of RAID 0 is that 2 hard disks store half of the data respectively. If one of the hard disks is damaged, it will cause data loss, and this loss is unrecoverable. The advantage of using this data storage method is the storage space is large, and the read and write speed is twice that of a single hard disk. But the disadvantage is that the risk of data loss is also great. Second, RAID 1. RAID 1 also requires at least 2 hard disks. RAID 1 storage mode has a fault tolerance mechanism. If one of the hard disks is broken, it will automatically switch to a normal hard disk. Of course, if you still want to maintain the RAID 1 function, you only need to add a new hard disk. The data is automatically backed up to the new hard disk without any influence on the content of the stored data. With this storage method, data security can be guaranteed. In addition, the write speed will not change much, but the read speed is about twice that of a single hard disk. The disadvantage is the hard disk utilization is only 50%. Third, RAID 5. This storage method requires at least 3 hard drives. RAID 5 can be understood as a compromise between RAID 0 and RAID 1. RAID 5 has similar data read and write speed to RAID 0, but RAID 5 has one more parity information. For example, the data packet is 123456789, put 123 in the first hard disk, and parity information is 1 plus 2 plus 3 equals 6. 456 is placed in the second hard disk and the parity information is calculated as 4 plus 5 plus 6 equals 15. 789 is placed in the third hard disk and the parity information is calculated as 7 plus 8 plus 9 equals 24. Parity information is stored alternately in different hard drives. If one of the hard drives is damaged, after inserting a new hard disk, the system will reconstruct the lost data based on the parity information stored in other hard disks. RAID 5 disk utilization is higher than RAID 1, storage cost is relatively low. RAID 5 is currently the most used solution. Fourth, RAID 10. RAID 10 requires at least 4 hard drives. Its structure is actually very simple. First, create 2 independent RAID 1 and then combine these 2 independent RAID 1 to form a RAID 0. When writing data, the data is written to 2 RAID 1 in order. For example, Disk 1 and Disk 2 form a RAID 1, Disk 3 and Disk 4 form another RAID 1. These 2 RAID 1 form a new RAID 0. Suppose writing the data packet 01234567. The data written on hard disk 1 is 1357, and the data written on hard disk 2 is also 1357, and the data written in hard disk 3 and hard disk 4 is 0246. Therefore, the combined RAID 10 has the characteristics of both RAID 0 and RAID 1. Although RAID 10 wastes 50% disk space, it provides twice the read and write speed and data security. If one of the disks is broken, the entire logical disk still works normally. When we need to recover the damaged disk in RAID 10, we only need replace with a new hard disk, perform data recovery. During the process of data recovery, the system can still work normally. The original data will be restored to the replaced hard drive synchronously. Every coin has two sides. RAID technology is the same. RAID does have a very good data redundancy backup function, but each RAID disk array has its advantages and disadvantages. In practice, we must combine the actual needs and reasonably choose the most suitable RAID technology to achieve the best results.